video is for today is about partitioning line segments, and the formula is in front of you, so check it out, write it down, make sure that you know it really well. It is x2 minus x1 times the ratio a plus b and plus x1 at the end. Okay, so it tells you what they stand for at the bottom, distance, ratio, and the first point. And so make sure you write that down, keep it in the corner of your paper as we do some examples. So our first example is shown to you, and so what we want to do is start by basically drawing out our line segment. So I have x is at -3, so I'm going to put that there. X, y is at 7, put that there, and draw a line segment. And I want to partition that into 2/3 ratio. And so we say this is going to be little a and little b. And our x1 point is the first point, and our x2 point is the second point. And so I'm going to plug those into the formula that you just saw on the previous page. And so when I do that, I'll get 7 minus -3 in parentheses, and then little a, which is 2, over little a plus little b, which is 2 plus 3, times, or excuse me, plus x1, which is -3. So that's the formula, that when everything is plugged in, that's what I get for the formula. So when I work it out, 10 times 2/5 minus 3. So we'll get t is equal to 4 minus 3, which is 1. T is equal to 1. So then I go back up to the top, and I want to plot t at 1. I plot it at 1 and make sure that it looks like it should be in the right spot. Okay, and so t would be in that spot, and we say this ratio right here is a key. Okay, so we say 2 to 3. The ratio 2 to 3 is the same thing as 2/5. Same thing as 2/5. So that's where this comes from. Okay, and it's all, it all comes from this right here. Okay, so basically this is two parts of the line. If I was to divide it up into 5 parts total, 2 parts would be there, 3 parts would be there. That's what that means. Okay, so let's go on and do another example. Let's do this example. So example number 2, it says x is at -5, so we start by plotting x, then we plot y at 7. Okay, and so these are really x1 and x2, and it's because it's a one-dimensional object. One-dimensional object, which means just a number line. And so we plot this line segment here to start, and then we want to use the formula and the ratio to find the rest. So this would be 7 minus -5 times 2 over 2 plus 1 plus -5. So I work this out, I get 12 times 2/3 minus 5, which will end up being 8 minus 5, which is 3, so t will be equal to 3. So I want to go back up and plot point t at 3, right here is t. Okay, t is at point 3, and so I want to make sure, does it look as if this is 2 parts of the line, 2 parts to 1 part, and it does. It does look like that. If I was to just divide the line up into 3 equal parts, 2 of them would be here, and 1 of them would be here. Okay, so that's where that comes from. Okay, so that is partitioning a line segment. Most of the examples are similar. Okay, we will partition 2-dimensional line segments, and when we partition 2-dimensional line segments, it will be just like a midpoint formula, where we'll do the x's on one side, so it will literally look like this: x2 minus x1, and then the formula that you just did, that will be on one side of the coordinate pair, okay, and then the other side of the coordinate pair will be this, y2 minus y1 times a plus b plus y1. Okay? So same thing, just like midpoint formula, where you're gonna work out one side, you're going to work out this side and put your answer right here. And then you're going to work out this side and put your answer right here. And you'll get, you will get a coordinate pair in the end, a number here, and a number here. Okay? So that's the idea of partitioning a line segment, and you can do that. Good luck.